Here out in the Atlantic, scientists are studying colossal ocean currents which have the power to alter life on Earth as we know it. The Atlantic circulates unimaginably powerful eddies called the AMOC. Now what scientists are trying to find out is whether climate change could radically alter the AMOC. Should it weaken or even switch off, that could cause a catastrophic paradox. Arctic winters in Western Europe as large parts of the rest of the world heat up. It's Tenerife. Winter sun, holiday getaway. Industrial scale global tourism banking on planet Earth's climate delivering as it always has and always will. But just across the harbour, here in Santa Cruz, a very different kind of cruise. Final preparations aboard the Royal Research vessel Discovery, British science leading the world. Casting off for critical research led by the UK's National Oceanography Centre based in Southampton to find out just what's happening to the huge ocean current critical to our climate. And so for the Discovery begins another vital chapter of Discovery. In this, the longest running ever programme of monitoring this vital oceanic current in the world. And you know, in the end, it's quite simple. In order to predict what this current is going to do in the future, we have to know what it's doing right now, measure it, monitor it, model it, and the implications of that for humanity could be profound indeed. Lead scientist Dr. Ben Mote on how a changing current could change our lives.
What is predicted to happen from these big mathematical climate models is that we would get a broad scale cooling in the atmosphere in the northern hemisphere. It means that basically we'll get very, very cold winters. So we would have stresses on our crops, on our agriculture, and basically on our health as well as a society.
Add to all that vast areas of the globe superheating and hotter, drier UK summers. So 8 days of critical research to understand and thus predict the engine of the Atlantic regulating our climate. The gigantic force that is the Atlantic Meridional Overturning Circulation, the AMOC current, Western Europe's winter radiator and summer watering can. The story begins in the warm waters of the Gulf of Mexico. There the current sweeps that heated water north, hugging the east coast of the US, then tracking northeast towards Europe. 1.2 billion tons of heat, that's more than 1 million power stations output, moving towards our shores, meaning our winters are way warmer than Canada at the same latitude. Then the current cools and loses strength as it begins slowly to move south past the east coast of South America, continuing down towards Antarctica before moving east off into the Indian Ocean. Meanwhile, warmer Pacific flow is seeping in, then going north past Africa's west coast, over to the Gulf of Mexico, and so it starts again. It takes around 1,000 years to complete this circuit. Or it should do. Trouble is, there is now growing scientific consensus that the AMOC is weakening, and could even stop, switching off Western Europe's natural central heating.
Yeah, it's going.
Global warming caused by human fossil fuel pollution is melting Arctic and Greenland ice at record rates. Scientists increasingly think millions of tons of this meltwater entering the North Atlantic puts a brake on the AMOC saltwater current.
So we've got the polar ice caps, they're sort of thinning. So there's more fresh water coming south into that sort of North Atlantic region, so between Scotland, Canada and Greenland, but also the glaciers on Greenland. They're also melting and putting fresh water into this North Atlantic region. And that region in the North Atlantic there is very sensitive.
So, down goes around £500,000 worth of monitoring and sampling devices into almost 10,000 feet of Atlantic, more than 2 Ben Nevises deep, if you like.
So this is a frame that's got a package of sensors on the frame, and they all do different things. So some of them will record the temperature of the ocean, some of them record how salty the ocean is. We have some that record light.
pond-dipping Atlantic style, measuring salinity, temperature and depth, key indicators of the ocean's current behaviour. Thousands of metres of cabling to the seabed and back, and all of it monitored and directed from the lab midship. Overseeing all this, Tillis Petit.
We need this data for different reasons, to just better understand how the AMOC is working, how the ocean circulation is connected to our climate, to everything. And we also need this data to also use them as a benchmark for climate models that are consistent with what we are actually seeing right now.
Polar melting might disrupt the North Atlantic current.
Yes.
Well, I think it's happening.
The Day After Tomorrow. The film came out 20 years ago. Apocalypse then. Hollywood's verdict on the AMOC stopping. Extreme perhaps, but the AMOC study began the same year this film was released, and real-life science shows this storyline may be playing out in slow motion, for the AMOC is weakening.
What we can say from the 20 years of observations that we have for now is that this AMOC has a slight declining trend. It's become weaker with time already, but we need more observation to have a better certainty on this trend.
And that slowdown has now to be mapped across time against the current's natural changes and cycles.
Well, what about that Hollywood Armageddon scenario, the switch off? Well, the scientific consensus is there is moderate confidence that won't happen this century, but it's very likely that there will be a decline next century. That's not exactly a clean bill of health. And even if there is a steady decline this century, that might not be smooth. There could be sudden dramatic shifts with real consequences for many of us.
So the need to know more and measure more is vital. A database for human survival could be emerging around the clock here, onto the decks and then into the labs of the Discovery. Countdown has started.
Half an hour.
Final preparations.
Double, triple check that everything is as it should be. If a mistake were to be made now, we'd ruin 2 years worth of work.
Send 10 minutes.
The faces say it. Tension.
After that bridge, 1 minute.
Teamwork.
30 seconds, stand by for countdown.
Concentration. Deep ocean science and engineering, very deep, approaching 10,000 feet.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Drop, drop, drop. All clear, nice one. Cheers, John.
They have to hit the exact drop spot in seemingly limitless ocean. That vertical cable of monitoring tubes will now lie mid-ocean for 2 years, assessing the colossal AMOC current, a key controller of Europe's climate. It's a challenging environment.
We do sometimes experience a shark bite on some of the moorings. We sometimes find fishing gear tangled up in it. All sorts can happen during the 2-year deployment.
Launching is one thing, finding them though after 2 years is another. Up on the bridge, all eyes on the ocean, as release monitors float to the surface.
So it's up. Yeah.
It comes down to grappling hooks before hauling all the monitors ashore. 2 years' worth of vital data. Fellow travellers from the deep encrusting this cache of analysis on the current, the temperature, the salinity and the depth. What they uncover here could very well paint a picture of what our future looks like. And all around us the monitors, monitored by the locals, long-beaked common dolphins, mother and calf, and a loggerhead turtle.
You might think this talk of the AMOC current switching off or shutting down is all a bit if, maybe, nah in the future. Just come with me now and have a look at this. There's hard scientific data right here, right on this ship, which blows that idea right out of the water, no pun intended. And this data's sitting on the computer of the chief scientist here. He's a busy guy, but come and look at this. Ben, hi, what have we got?
So here we have the strength of this AMOC, this Atlantic Meridional Overturning Circulation.
Left to right across 20 years, the lines are falling. AMOC is weakening as Arctic and Greenland ice melts because of our fossil fuel pollution. What's gone on there? 2009? That doesn't look good.
2009, 2010. What happened was like it was a perfect storm where sort of everything came together. So the winds reversed, the AMOC reduced, and basically the amount of heat that was coming up towards Europe reduced by about 30%.
By a third?
By 30%, by a third,
wow.
Yeah.
The very next year, 2010, the coldest UK December for 100 years. Complex atmospheric conditions were in play, but it appears the radically weakened AMOC was a contributing factor. But that wasn't all. At the same time, across the Atlantic, the ocean surged in New York City.
So we had sea level rises in the USA, in New York, on that side, of 13 centimetres.
Wow, that is some warning. So we know, even purely naturally, that if there's a big anomaly in this current, you get massive consequences.
Yeah.
We have been warned. So we now have proof of what happens if even natural weather conditions can cause the AMOC to be radically weakened. But what if burning fossil fuels causes freshwater ice melt in the Arctic to create another 2009, but long-lasting, permanent even? Midship, here in the lab, they're modelling the data over decades to try to answer that huge question. Adam may have to drill his computer into the desk in case the Atlantic swell gets up. But once safely logged in, modelling from the 1970s to 2023 shows the AMOC's warming water crossing from Africa to the Caribbean, heating in the Gulf of Mexico, then an intense stream east of North America and across towards Europe.
So we can start to look at how things correlate at different latitudes, how coherent these circulations are and how robust they are over different timescales. We can use the models to go further back in time. We get a clearer picture of what has been happening over, say, the last 4 or 5, 6 decades.
But these scientists, leaders in their field, know they're now in a world where some political leaders deny reality, reject the physics of climate breakdown. So if you're the boss of this operation, doesn't that simply make your blood boil?
As you know, we're all about getting the evidence, we're all about gathering the information that's needed for people to make good decisions, and that's absolutely what we want people to do. What we tend to find actually, particularly in this government, is the vast majority of people really do understand and get it, and it's about creating an environment in which people can use the information we've got effectively.
By night, another strand of analysis, this time part of a global operation. 4,000 research floats like this across all oceans of the planet. Scores of nations involved, building data for political leaders to take fact-based, physics-based decisions. So, will they?